For thousands of years, humanity has looked upward, searching for meaning in the night sky. We traced patterns between stars, built stories around them, and eventually began to decode their behavior using mathematics and physics. Over time, a powerful idea took shape, that the universe operates according to consistent laws, that with enough effort, we could understand its structure, its history, even its future. That belief has guided generations of discovery. From gravity to the expansion of space, each breakthrough added clarity to the cosmic picture. It felt as though we were slowly turning mystery into knowledge. But now, that picture is being challenged, not destroyed, but unsettled. A new wave of observations is revealing a universe that behaves in ways we didn't fully anticipate. Not in contradiction to physics, but in tension with our expectations. At the center of this shift is the James Webb Space Telescope, a machine designed to look deeper into space, and further back in time, than any instrument before it. When it began its mission, scientists expected sharper images and more precise confirmation of existing theories. Instead, it delivered surprises. Looking into a region known as Abell 2744, a massive galaxy cluster that acts as a natural gravitational lens, Webb captured light from some of the earliest galaxies ever seen. These galaxies existed when the universe was still very young. They were expected to be small, irregular, and just beginning to form. But many of them weren't. Some appeared bright, massive, and structured, as if they had already gone through long periods of evolution. Their existence suggests that galaxies may have formed faster than our models predict, or that the early universe behaved in ways we don't yet fully understand. The deeper we look, the more complex things appear. Across enormous distances, galaxies are not scattered randomly. They form patterns, clusters, arcs, and vast interconnected structures. Gravity can explain the formation of structure over time, but in some cases, the scale and speed of these formations push the limits of current simulations. They don't break the rules, but they stretch them. Even more intriguing are phenomena like near-perfect Einstein rings, luminous circles formed when gravity bends light from distant galaxies into symmetrical arcs. This effect was predicted by Albert Einstein and is well understood. But the level of precision required for such symmetry is extraordinary. Across billions of light years, objects must align almost perfectly. It's rare. And yet, we're finding more of these rare alignments than expected. Then there are entire networks of galaxies, the cosmic web, stretching across hundreds of millions of light years. These vast filaments connect clusters like highways through space. While simulations predicted their existence, some observed regions display patterns that seem unusually regular, almost rhythmic in how galaxies are distributed. Most scientists attribute this to gravitational evolution. But some are beginning to explore deeper possibilities. One of those possibilities involves dark matter, the invisible substance that makes up much of the universe's mass. We can't see it directly, but we know it exists because of how it influences gravity. Now, a more speculative idea has entered discussion. What if dark matter behaves in ways we don't yet understand? What if it plays a more active role in shaping cosmic structure than we assumed? These ideas are not confirmed. But they are being considered because the data is becoming harder to ignore. The surprises don't stop at galaxies. Planetary systems are also raising questions. One example is HIP 65426b, a massive gas giant orbiting far from a very young star. Based on traditional theories of planet formation, there shouldn't have been enough time for such a large planet to form at that distance. And yet, it exists. It has shown us that the universe is richer, faster, and more complex than we imagined. And that realization changes everything. Not by giving us final answers, but by revealing how much more there is to discover. So we continue to look upward. Not with certainty, but with curiosity. Because the deeper we look into the cosmos, the more we realize that the story is still unfolding, and we are only at the beginning of understanding it.